We're solving equations with variables on both sides. Our first example is 10 minus 4x equals negative 9x. The first thing that you want to do is get the variables all to one side. It doesn't matter which side. It could be left, it could be right. I personally, when I look at this, I would want to move this negative 4x to the right, because if I move the negative 9x, then there'll be nothing left on the right side, and I'll just have to move something over there anyway. So I have, and if you do it the other way, it doesn't matter. If you move to the other side, it doesn't matter. You'll end up with the same answer in the end. Okay? So I have 10 minus 4x. What's the opposite of minus 4x? Plus 4x. So I'm going to add 4x to both sides. So minus 4x plus 4x is 0. So on the left, what do I have? 10 minus 0, or just 10, equals negative 9 plus 4x. Negative 5x. Don't forget your variable. Sometimes I have students whose variables just miraculously disappear. Don't make your variable disappear. Okay, so now I have still not isolated my variable. I need to isolate the x, get it all by itself. So I have 10 equals negative 5x. When I have a letter and a number smooshed together, what operation is happening? Multiplication. What's the opposite of multiplication? Division. So what am I going to divide by? Negative 5. Don't forget the negative. 10 divided by negative 5 is? Negative 2. Negative 5 x's divided by negative 5 is? 1x. Yeah. But there's no constants or coefficients. Okay, so negative 2 equals x, or x equals negative 2. But I am going to check it, and I'm going to expect you to check it, okay? So the way we check is we use substitution. So we rewrite our problem, 10 minus, our original problem, sorry, minus 4x equals negative 9x. And then we substitute what we got for x into these x's, okay? So 10 minus 4, I always use parentheses so I can easily see what it was that I substituted in. So now I have 10 minus 4 times negative 2 equals negative 9 times negative 2. Order of operations says I multiply first. So I have negative 4 times negative 2, which is, so I have 10 plus 8, because when I have two negatives, it becomes a positive, and I use that sign, equals negative 9 times negative 2, which is positive 18. What's 10 plus 8? Does 18 equal 18? Good job. I know that checking feels like it takes an unnecessary amount of time, but you're basically guaranteeing that you did it correctly. You're guaranteeing yourself an A on a test. Okay. Let's do another example. Any questions about the first example? Okay. We have 3 times 3x minus 4. So we're doing 3 times that whole thing, equals 1/4 times 32x plus 56. Okay. So the first thing that I would do is distributive property. So distributive property says I do this times 3 times everything. What's 3 times 3x? What's 3 times negative 4? Negative 12. Okay. So 1/4 times 32. The word times just means of. So 1/4 of 32 is 8. Or 32 divided by 4 is another way to think of it. 1/4 of 32 is 8 x's. 1/4 of 56. I'm having to think about it. 14. First, what I did 56 divided by 2, which is 28. Then I did 28 divided by 2, which is 14. Yep, same thing. 8 times 7 is 56, so that means 4 times 14 is 56 because 8 divided by 2. Okay, if you can't do it in your head, you guys get calculators. I'm just doing it in my head. Okay, so now I have a problem that looks pretty similar to the top one. So I want to get my variable terms to one side. You could subtract the 9x and bring it over here. You could subtract the 8x and bring it over here. It doesn't matter, you'll get the same answer. But I don't want to work with negatives unless I have to. So I'm going to bring this 8x over because then I know that I won't end up with a negative answer. Because I subtract 8x, subtract 8x, 9 minus 9x's minus 8x's is 1x minus 12 equals 8x's minus 8x's is 0, so I just have 14. And now I have x minus 12 equals 14. How am I going to get the x isolated? Plus 12. So on the left I have x just by itself because negative 12 plus 12 is 0. And then I have 14 plus 12, which is 26. But now we got to check. Okay. I feel like this check is going to take longer because of all this stuff. So let's check it. 3. I'm going to rewrite my problem. 3 times the quantity 3x minus 4 equals 1/4 times the quantity 32x plus 56. Okay. Now where I see the x's, I'm going to substitute the 26 because that's what I think x is or what I got for x. So 3 times the quantity 3 times 26 minus 4 equals 1/4 times the quantity 32 times 26 plus 50. This is where a calculator will really come in handy. You could do it without a calculator, but do we really want to do it without a calculator? No. Okay, so 3 times 26. If you have your calculator handy, someone type that in for me because I don't have my calculator handy. 3 times 26 is 78. Are you sure? Because that didn't sound sure to me. I'm not saying you're wrong. I think it's 78. You didn't sound very confident.
I just did it on my paper.
78 minus 4 equals 1/4. What's 32 times 26? That's the one that I'm not wanting to do. 832. Close. Okay, so now I just have constants. Okay. Order of operations says do what's in the parentheses still. So I have 78 minus 4, which is 74. So now I have that. There, I know that if I was doing this by myself, like not in front of you guys, I would be skipping steps because I would have like typed this in the calculator when I did this and like typed it, you know what I mean? I wouldn't do it all separately. But so I realize that when you do it yourself, you might not chunk it out this slowly. 832 plus 56 is 888. I'm asking you guys too, just to make sure. So hopefully you're gonna tell me if I'm wrong. What's 3 times 74? 222. And 1/4 of 888, or 888 divided by 4 is 222. So we did it right. I'm so proud of us. Okay, one more example and then I'm going to let you get started. I realized that our fire drill kind of cut into our assignment time. Sorry. I know. I only have one more example though, so I should be okay. Okay, our next example is, actually it's a 2-part example, so it's kind of actually 2 more examples. So I lied. 3 times the quantity 5x plus 2 equals 15x. Okay, distributive property first. So what's 3 times 5x? 3 times 2. 6. So I have 15x plus 6 equals 15x. What do I need to do? Yeah, I have one more example, okay, and then I'll be good. Okay. Okay, sorry, what? Subtract 15x. 15x minus 15x is 0, so I have 6 equals 15x minus 15x is 0. Now what? No solution, because does 6 equal 0? No. If you looked right from there, that point, can 15x plus 6 equal 15x? No. So if you could figure it out from that point, you don't have to do the other stuff. You could have just written no solution. Okay, see, that was fast. No check, because there's not anything. Can you plug anything in to check it? No. All right, one more, and it's just as fast. So, negative 2 times 4y plus 1 equals negative 8. Do you want me to move there? Negative 8 negative 8y minus 2. Same steps. Distribute first. What's negative 2 times 4y? Negative 8y. What's negative 2 times 1? Negative 2 equals negative 8y minus 2. What do I do next? What? They're the same. Both sides are the same. They equal each other. So that means that no matter what you plug in for y, it'll work. So, what? You were going to say something.
I was going to say, like, it's not no solution, it's like
anything. So infinitely many solutions. So you could do the symbol for infinite solutions, or you could just honestly write infinite. Okay? It's like a sideways 8. Okay, so I have posted onto Google Classroom the PDF book pages because I'm not sure if your books will load yet on the website. You can still try it. Your assignment is, I think I remember off the top of my head, 4 through 18 even, and then 19 through 27, I think, all. It's on Google Classroom if you want to check it. All right? I'm going to stop recording while I'm saying this. You